So just a sort of quick show of hands. There we go. Who here is working with microservices right now? Great. Who's very happy with that? Most. Who's run into challenges? Good, that's about right. So I'm going to talk about kind of microservices from a perspective of, a little bit upfront about what are they, what do you use them for, what are some of the cool things that you can get out of it, but then also spend a little bit of time on what are the challenges, what are the things that you have to be good at in order to really take advantage of microservices. And so kind of to start with, microservices are really, it's an architectural pattern for building distributed services. And it's really kind of juxtaposed against, what we call monolithic services. And really the idea here is to break things down into a suite of services that talk to each other over the network, each one running in its own process, each one exposing some sort of API, very frequently through REST, but not always. The key really to, where microservices get really interesting is that they're independently developed, they're independently deployed, and then each service kind of focuses on doing one thing well. And the thing that gets everybody excited about microservices, and I think rightly so, is this notion of independent development and independent deployment. And in a couple of slides, I'll talk a little bit about Fred Brooks and his Mythical Man Month, and about how there are teams now that are actually able to kind of not break, the Mythical Man Month sort of concept, but certainly work around it and mitigate it by deploying microservices. And a quote here from Robert Martin about, one of the guiding principles for microservices is sort of well put by this quote, which is, all those things that change for the same reason should live together, and things that change for different reasons should live somewhere else. And that sort of alludes to one of the key aspects and one of the key challenges of doing microservices well is doing the service decomposition well. If you get the service decomposition wrong, you put yourself in a world of hurt, and you lose a lot of the benefit. And so I'll talk a little bit about what what people say in terms of how to decompose your services, what to look for, things like that. So what's cool about microservices? There's really kind of two things that people talk about mostly, and there's loose coupling and there's cohesion. And loose coupling is really where we get a lot of our power. Again, this is because we can choose tooling that's appropriate for whatever problem we're serving, we're trying to solve in that service. If you want to use a NoSQL backing store, you can do that. If you want to use Ruby for this service and Groovy for this one and Clojure for that one, you're kind of free to choose technologies that are fit for purpose, right? And that's very difficult to do in a monolithic application, because in a monolithic application, you've got pretty much a monolithic technology stack. And so you're oftentimes kind of squeezed into making tools and products and those kinds of things do things that they may not really have been designed to do, such as putting graphs into RDBMSs, or putting documents into things that aren't document stores, and those kinds of things. Operationally as well, the notion of loose coupling is interesting, because that means you can scale just those services that you need to scale and not worry about the others. Whereas in a monolithic application, you kind of have to scale everything in order to scale anything. The life cycle of each service can be independent of everybody else. So I can rip apart how I implement my service and replace it. And as long as I don't change the contract, as long as I don't change the API with how my consumers consume my service, nobody will be any the wiser. And that's a pretty powerful thing to be able to do as you evolve your services, as you realize that, we didn't really architect this one correctly, we really need to do more caching, or we need to use a NoSQL store, or what have you. You're much freer to just kind of play around inside of that service, and are much more independent. And it makes it a lot easier to adopt new technologies, because you don't have to adopt a new technology for your entire application. Right? It'd be pretty difficult for a large monolithic application written in Java to all of a sudden say, well, we're going to do it all in Erlang, right? That would be an undertaking. Whereas if you decide that Erlang is a good tool for a particular service, have at it. You know, if it doesn't work out, it's not a big deal. You just figure out what the next thing to use is and go with that. So you're able to kind of do much more small, you know, much smaller experiments and play around with technology a lot more with microservices, which is a good thing. And then kind of getting to the Fred Brooks part of the whole thing. Smaller, more autonomous teams are more productive. You know, I think that's some people would claim that that's been proven, you know, that it's a theorem, it's a law. Some people would say, no, it's not. But I think by experience, you know, a lot of us would say that, you know, as our teams grow and the amount of communication that we have to do and the amount of coordination that we have to do, frankly, we spend less time writing code. You know, we spend less time writing tests, we spend less time, you know, working with customers and iterating and, you know, all of the things that we need to do in order to bring out quality software. So there's a lot of cool things about microservices that draw people to them. Now, you know, if you've been around in the industry for a while, you might sort of legitimately ask, well, isn't this just SOA all over again, service-oriented architectures, right? And really the answer is sort of yes, but it's a little bit of, and I wouldn't say this necessarily that it was a conscious decision on the part of the community, but SOA was meant to solve the monolithic application problem, but it sort of never, I don't want to say never caught on, because it certainly caught on in some sense, but it really became more about selling middleware than anything else. And it really became, you know, buy my enterprise bus, do everything with an enterprise bus, and, you know, all of that kind of stuff. And it tended to be a little bit more prescriptive about the technology stack, right? You know, web services and WSDL and using SOAP and all of those things, whereas microservices are really kind of hands-off on the actual technology decisions, right? All it's really saying is decompose your problem, have good boundaries between the services that you want to do, come up with an API that makes sense, pick an API technology that makes sense, and then go implement that in whatever way, you know, you think is necessary. You know, whereas I think in the SOA world, it was much more kind of prescriptive, and, you know, if you bought into this middleware technology, then all of a sudden you were, you know, stuck with WebLogic or stuck with WebSphere or, you know, those kinds of things. And that mandates a lot of, you know, technology decisions that kind of lock you in, which, you know, just that kind of kills innovation in a lot of ways. And didn't really kind of get into a lot of the kind of nitty gritty about, okay, fine, I have my monolithic application. What do I need to do to break it up, right? What do I need to do to fix that? Which is really, you know, which is really the important part that you need to worry about if you're thinking about adopting them. And so kind of what I like to say is that microservices kind of evolved out of real world problems. You know, people were looking at what they were doing and realizing that, you know, if I need to make a change here, I've got to deploy the whole damn thing, and that's no good. And that means now I'm stuck in whatever, you know, deployment frequency we can do for our large monolithic application, which is probably less frequent than if we were deploying smaller services. And so it takes me longer to get my code out into production, which is not good. So, you know, another approach that people often take to this is, well, I mean, can't I just do good code hygiene? Can't I just modularize and use shared libraries? Isn't that the same thing? Isn't a shared library a contract? It has an API that it exposes and all of those kinds of things. And I mean, modularization and shared libraries are absolutely good things and things you should use, but it's not really a good foundation for an architecture for a distributed system, right? You've got much more technological coupling. Typically, if you're using shared libraries, whether it's, you know, DLLs or shared objects or jar files or what have you, it ties you to another kind of technological stack, right? If you're using Java, it's going to be all jar files, and maybe you want to use OSGI and all of that kind of stuff. But it really kind of ties you to that. And that starts to also cause API coupling, right? Because I can, you know, I'm linked to a whole bunch of different libraries. Library A is using library B, and I'm supposed to use only library A, but I can very easily, you know, start making calls into library B if I can. So it really, you know, having a process boundary where you just don't make a method invocation, right? You have to send a message somehow. Really, really helps to enforce good API hygiene. Now, it also makes it more important that you get good at defining what your APIs are. That's going to be a pretty important thing as we look at how we get to microservices. But first a little bit just sort of about, what about monolithic apps? Are they evil? Should they go away? And the answer generally is pretty much no. Not everything needs to be a microservices app. Not everything needs to take on the added complexity, and there is added complexity in dealing with microservices. If you've got a monolithic app, they can be a lot easier to test. I could fire it up inside my IDE and I can run unit tests, I can run service tests, I can run I can run any kind of test from my desktop pretty much. As long as I have a database to talk to and a web server in front of it and that kind of stuff, I have a lot easier time to do that kind of testing. And for the same reason, it can be easier to develop because I have access to all my code. It's right in front of me. If I do a refactoring, boom, everything gets refactored easily. And they can be easier to deploy, right? I mean, it's definitely the case that if you've got a monolithic app, you pretty much are only going to be doing one thing when you deploy it. Drop that WAR file in, or drop that DLL in, or drop that executable in, and you're kind of done. Deploying microservices is a little bit more involved. There's more moving parts, but there's a lot of downsides, right? You can't deploy anything until you're ready to deploy everything, and that's a big deal. The code is going to be harder to learn because it's going to be a larger code base, and it will also kind of be subject to kind of code spaghettification, right? You can very easily, you can write bad code no matter what architecture you choose to use. So let's just say that. But it's easier in a monolithic application to sort of reach into some place where maybe you're not supposed to be and make changes in order to make your stuff work. And now you've created a coupling between two pieces of code that weren't necessarily coupled before. And as I've said before, it's harder to adopt new technologies, right? Because you kind of have to adopt it across the entire monolith, and that is difficult to do, and rare that happens. And similarly with scaling, if you want to scale it at all, you've got to scale the whole thing. And what does that mean? That can be a tricky thing. If you've got a single instance application and it's talking to an RDBMS, and now all of a sudden you've got to split it apart and run it horizontally, you got a bunch of things you got to worry about. You've got all this shared state, all of those kinds of things. And actually, those are some of the things that you have to worry about when you start to break up a monolithic application. Is how do you deal with things like shared state, with things like caching and database access and those types of things. So there's been a lot of talk recently in the community about, driven a little bit by the 2015 State of DevOps report, where they talked a little bit about, look, the ability of high-performing organizations. And if you haven't read the report, you should go read it. It's pretty short and has a lot of really good data in it. But the point of this graph kind of being that high-performing organizations, those that are really good at CI and CD and really apply DevOps principles and Agile principles and those things, are exponentially better at doing things like deployments and especially doing frequent deployments, right? And doing so in large teams, large-scale development teams. And so kind of the question kind of naturally comes up, was Fred Brooks wrong? Hopefully. So show of hands, who's actually read the Mythical Man Month? Wow, that's not a lot of people. Who knows about the Mythical Man Month? All right, that's much better. I mean, the point of the Mythical Man Month is very simple. It's you really can't make a team more productive by adding more people to it. Because of, for a lot of reasons, but the communication between all the various members of the team starts to kind of blow up, and you spend more time communicating than working, and all of those kinds of things. And it comes out of a lot of real world stuff that Fred Brooks did when he was, I think when he was working at IBM, working on the 360 or something like that. And so the notion that, with using a lot of these technologies, that we can start to circumvent this notion that we can't be more productive by adding more engineers is really kind of interesting. Now, the thing though is, it's not that Fred Brooks was wrong, but what it is with microservices and small independent teams working on independent services, you kind of don't break the law. You've got small teams and they're effective and they work independently, and I don't need to know what the other team is working on. That's their problem. They publish an API to me, I consume it. I publish an API to my consumer and they consume it. We need to negotiate and establish what the API is going to be, but that's something you kind of have to do anyway, and then we're off to the races, right? And I can use whatever technology I want, you can use whatever technology you want, and we meet in the middle and good things happen. So I mean, really, truly, if you want to scale an organization, and we're talking hundreds and thousands of engineers working on a single massive application, microservices is definitely something you want to look at, right? The monolith is going to hurt you. It's going to make it painful to really get that sort of deployment scale that you're looking for. Not that it can't be done, and some companies do still do it, but it's a heck of a lot easier if you if you divide and conquer. I mean, that's not a new concept. So no, Fred Brooks wasn't wrong, but we can cheat a little bit. So another question I get pretty often is should we be using microservices? Should I use it? Is it right for me? Am I ready for it? Those kinds of things. And what I would say is if you've got fairly solid CI, if you're doing automated testing, you're doing automated deployments, and you're looking to scale, either scale the application or scale the teams, then maybe, right? You maybe want to try looking at that. On the other hand, if you're shipping on-premise software, then microservices probably isn't right for you, right? And actually, I mean, it's interesting because in our case at Electric Cloud, we for the most part ship on-premise software. So we don't really ship microservices because our customers have to be the ones running the product. And we don't want to put the burden on them of doing what you have to do operationally in order to really benefit from microservices. And besides which, even if we did it all as microservices, they wouldn't let us deploy updates anyway, right? They're not going to let us update their software running in their data center. So kind of there goes our advantage for using microservices to a large extent. And I would say definitely, if you don't have something like automated testing, then you should absolutely worry about that first, right? Microservices are going to not help you at all if you don't have things like automated testing and good automation in general. One of the key things about the kind of the microservices journey is you're going to be making a lot of mistakes as you start to break up your monolithic app. And you're going to need to have kind of the safety net of a good testing infrastructure to know whether you screwed it up or not, right? That's really, really critical. If you don't have that, focus on that first. You're going to get a much bigger bang for the buck out of good testing automation and getting that ready before you even worry about microservices or any new sort of cool topics that are out there. You also have to be or become pretty proficient at doing things like automated deployments, automated testing, and especially monitoring, and I'll talk about that a little bit more in a few slides. And so the conclusion at the bottom of the slide here is that microservices are not a magic hammer that whatever ails you, it won't fix, right? It is a very specific architecture for some very specific types of problems to solve. You need to scale a team, you need to scale an application, you're not able to deliver fast enough, those kinds of things. But there's a lot of prerequisites too that you need to either realize that you need to be good at or get good at in order to really take advantage of microservices. So, are you ready for it? The consensus seems to be, and thanks to Martin Fowler for his great illustration there, the consensus seems to be, so let's say that you're not starting with a huge monolithic application, but you're starting with a green field. What a lot of people are saying, and I think it sort of makes sense, is if you're starting out, go monolithic in the beginning. Modularize and componentize and have good hygiene and start to think about where the seams might be. But early on in the process, you're not going to understand enough about your problem and your problem space to be able to say, here are all the services I'm going to need. Right? Now maybe you can say one, like, okay, authentication, that seems like an easy one, so that might be true. But in general, until you understand your domain model, until you understand your customers and what you're trying to do, the general consensus seems to be stay monolithic and start to break things out as patterns start to emerge. And it sort of reminds me of when people set up a forum online, and sometimes they put up a forum and there's one topic at the beginning, and it's just anything goes, and then organically that grows and more topics get added and those kinds of things. And then there's the other way of doing things, which is somebody sets up a forum and they immediately think of 28 different topics, right? And like 3 of them get used and the other 3 are empty forever in time because they overthought it, right? They thought, well, here are all the things that should happen. And I think people, there's a tendency to do that when you start thinking about services as well, that you want to do kind of premature decomposition. You want to, it's just as evil as premature optimization, right? You really want to understand your problem better before you start to try to decompose this thing. And really a lot of that has to do with just, it's expensive to change services across services, right? You now have to do coordination, you now have to do lockstep releases. If I decide that, this particular API, which has been living in service 1, really needs to live in service 2, because otherwise it's too chatty between those two services, I now have to release those two services in lockstep or maintain multiple versions of the same service at the same time in order to, in order to not force my consumers to change. So wait as long as you can before deciding what the service structure should be if you're starting from scratch. And as I sort of said before a little bit too, you have to be good at infrastructure provisioning, because you're going to go from one machine, one type of machine, to lots of machines, right? And especially if you're going to do, if you're going to get serious about it and you're going to have dozens or even hundreds of microservices and you're going to start scaling them, you're going to have lots of infrastructure that you need to manage and create quickly. So you need to be good at that. You need to be good at rapid application deployment. You need to be able to automate all of those things. And as I sort of said before, and I'll sort of keep beating that a little bit more, you got to get good at monitoring, because it's more critical with microservices even than with monolithic applications. So what's difficult? I think I've sort of alluded to most of these already, but the service composition, getting that right is tricky, and it's very important. You'll get it wrong, so just accept that, and look for ways to adjust it and kind of fix it over time. Breaking up a large monolithic application, that will take time. Not days or weeks, but months and years probably for a large application. It's still worth it. There's going to be a lot of challenges. You need to have somebody in a role who's kind of the overall architect of the system, either one person or a group of people, and who really understand the flow of the data, where the logic is, where the behavior is, all of those kinds of things. And that can be difficult in a monolithic application, right? It's equally difficult in a microservices application, but once you've done that decomposition, you can be an expert in a small area, right? And you can build expertise there, which is pretty handy. Whereas to really break apart a monolithic application, you're going to have to understand it, and so that you don't screw it up. And once again, beating the hammer of monitoring. And a quote here from Ben Christensen at Netflix that I liked, and the emphasis is mine, but it's got to be a cohesive system. A lot of small parts working autonomously, being deployed independently with independent life cycles, but they all got to come together and work, right? If some service isn't behaving properly, then you got to fix it, and it's difficult sometimes to figure out what the problem is when you're there. So let's say that you've decided that you want to go down the microservices route. What are you going to do? How are you going to get there? So what makes a good microservice? There's kind of two things that people look for in general. One is loose coupling, right? So the general gist being that you want these things to end up being independent, right? So you don't want any change to one service to mandate a change in another service. If I make a change to some internal piece of my service, that shouldn't reflect out into my consumers. I should be able to change my implementation. I should be able to change my caching strategy. I should be able to change my complete technology stack, and my consumers shouldn't care, right? As long as I satisfy that contract that we've established up front. And typically what people strive for are kind of small, very tightly focused APIs. If a service starts to become kind of bigger and bigger and bigger and bigger, it's maybe time to start looking at, should we chop this thing in half? And is it really doing more than one service should be doing? The more you get kind of outside of that tightly focused API space, the more coupling you're going to introduce, and the more chances are that every time we make a change in something, we're going to have to make a change in this service as well, which is not what you want. And the second factor to look at for microservices is high cohesion. So things that belong together should be together. right? And there's sort of a coupling thing here as well, which is if you have a type of logic or some behavior that you've implemented, and you have that behavior live in more than one service, you've got a problem, right? Because if you want to change that behavior, you now have to rev multiple services. And again, you're starting to lose the benefits of loosely coupled architectures. So, one behavior, one thing that it does well, try not to replicate that behavior out into other places. There's always going to be a little bit of a kind of a tension between, is this really sort of utility stuff that should be in a utility library that every service uses and that kind of stuff? And I think there's a place for that. The danger of that, again, is if you start building lots of utility libraries, you're now mandating technology choices for other services in order for them to consume it, right? If I write some sort of hashing algorithm or some sort of image processing thing and other services need it, if they have to link into my library in order to use it, that's no good, because now I've coupled these two things together. Much better to expose that as an API and be able to use it that way. And in general, kind of domain-specific behavior belongs, in one service. So if you're doing a finance thing, that should be in kind of the finance service. If it's a warehouse thing, it should be, in the warehouse service. But grossly oversimplifying, obviously. But you really want to think about how you decompose the real world. And things like domain-driven design can actually be pretty helpful in understanding these things, which actually is on this next slide. So you've got a monolith. You want to break it down. You're convinced that microservices are going to, be the end-all and be-all for what you want to do. First of all, don't do this as a big bang rewrite. Don't go off and delete all your code, and if you do, keep your tests, but don't go off and start from scratch, right? That's going to be very expensive. You're much better off looking for what people call seams, sort of boundaries between code that seem to split things apart in interesting ways, that don't interact with each other, and those kinds of things. They're kind of focused around a single business capability. And in domain-driven design, which I have to admit I'm not super familiar with, but I hear about all the time, there's this notion of domain contexts. And that actually has proven to be a fairly useful kind of technique to use in breaking these things down. You're looking at what are people doing, where's the data flowing, what are the requests that go between organizations, those types of things. That tends to be a good framework for starting to decide how to break down your monolith into separate pieces. The other thing to do too is, if you've got an area of code that needs to change a lot, maybe you're adding a lot of functionality to it, or you need to fix a lot of problems in it, that might be a good candidate for breaking out into its own service, right? If you break that thing out and you need to change it a lot, you're now in an independent lifecycle, so you can sort of do that independently from the rest of the monolith. So again, it's sort of divide and conquer. Don't ignore organizational structure, and that's a pretty important one. And Conway's law, in case you're not familiar with it, basically says that the output of an organization will mirror the structure of the organization, and especially the communication in the organization. And in the nerd industry, the way I usually put that is, or the way people usually put it is, if you have 4 people building a compiler, you're going to get a 4-pass compiler, right? That's just how it is. And so you want to be careful not to say that, here's one team and they're responsible for 4 services. Or here's a service, but it's really implemented by these 3 different teams, because you're going to start to sort of lose the loose coupling, lose the independence, lose the life cycle, and all of those kinds of things. So it may very well be necessary to break teams apart, or to form smaller groups of them, right? And especially if you want to get to the part where you end run around the mythical man month, you want to keep the team small. You definitely want to keep them small. As you're starting to look at the code, dependency analysis tools can be pretty useful. They're not going to sort of magically tell you where the boundary lines are between your services, but you can definitely start to look at code and say, look, this whole module or this whole package doesn't touch anything else in the world. This is a candidate for pulling it out. And so those kinds of tools can be helpful as well, at least to get a start on how to crack this thing open. Now, one of the hardest things that people run into, I think, is what do you do with your data? Especially if everything is in an RDBMS. To start with, you are going to have to understand your schema really well as you embark on trying to tear this thing apart. In particular, you're really going to want to understand where you have foreign key constraints and why. Because, I mean, one thing you're absolutely going to be doing is breaking up your database into separate pieces. Some of it may be going into another RDBMS. Some of it you may decide to put in a key value store or a document store or something like that. So where you have foreign key constraints, you've got to understand why those constraints are there. Are they there for a business reason? Is it okay if I move this table over here and I move this table over here and I don't have a foreign key anymore? I may need some cleanup work that I do every once in a while to kind of establish consistency between the two or those kinds of things. Shared mutable data is another thing that you sort of have to worry about. If you have an object and you have multiple services that can mutate that object, you're going to have to figure out what to do about that, right? Because now how are you going to reconcile those changes? And transactional boundaries as well. If you have a number of changes to the database that happen in a single transaction, do they all have to happen in that single transaction, right? Can you break it apart into multiple transactions? Can you put a messaging layer between transaction 1 and in service 1 and transaction 2 and service 2 and do it that way? You may well be in a situation where you break this up into multiple transactions and the second transaction fails. So you need to handle that, right? You may need to have a compensating transaction that rolls back essentially the first transaction. Or, God forbid, you may need to look at distributed transactions, which are kind of a big, hairy thing to do, can introduce all kinds of coupling and difficulties as well. So I think in general, people kind of say, don't use distributed transactions unless you absolutely positively have to, right? Stay away from that because it's going to introduce coupling. Instead, think more about, do I really need 100% ACID in all of my transactions? Can I put some things into different kinds of stores? Can I break my tables apart? Because you're going to have to do that because the database schema is going to probably be your largest and most tricky source of coupling between everything. And you really have to go in and start to hack away at that and break them apart. And I think for most applications, that's going to be the most difficult thing to do. And another technique that I've seen mentioned quite a bit, and which sort of makes sense on the face of it, is split your data before you split the code. So if you're going to say, okay, I have one table today, it has my my line item, my stock item table has a price in it, and it also has a quantity for how much I have in stock, and those really need to be in separate tables, handled by separate services. Split that table before you split the services and split the code and make sure that it sort of works the way that you intend it to. Less moving parts, less variables, it's always easier to kind of adopt change that way. And kind of lastly, are there places where you really need an RDBMS? I mean, I love databases. I've used them for 25 years. They're great. They don't forget stuff, and they keep us from making mistakes in the data and all of that kind of stuff. But there's a lot of data that we store in there that isn't really it's not really RDBMS type data, documents and I would say eventual consistency is a decent thing if you're building, if you're Facebook, for example, one of the kind of techniques they use is, and they're not really microservices, but it's sort of relevant to the database aspect of this. If you post a comment, right, then you are sort of routed to a server that has very up-to-date data. On the other hand, if you're just browsing comments, you're reading typically a replica of data, right, for scaling purposes. You may not actually be seeing the very latest data. After a few minutes of making your post, you get shifted back to the read-only copy with the understanding that most likely your changes have propagated to the replicated copy, right? So there's all kinds of things that you can do in terms of scale when you start to understand how your users are behaving, right? If it's 90% browsing other people's posts and 10% creating new, you can optimize for that and do all kinds of interesting things with the data. So the RDBMS is not necessarily the panacea for everything. Storing graphs in RDBMS is not fun. It's really a square peg in a round hole. So NoSQL, key value pairs, document stores, those kinds of things. It becomes, the nice thing is it becomes possible for you to do that because you're looking at your service, you've got a particular use case that you're trying to figure out, and you don't have to worry about all the other services, right? So it's a lot easier to again, to adopt new technologies. So how large should a service be? You know, as small as possible, but no smaller is sort of what everybody says. I don't know if anybody, you know, gets the Spinal Tap joke, but I threw that up there anyway. Now, the smaller the service, the more decoupling you're going to get, right? So that's a good thing. A rule of thumb that I've heard, and somebody was very specific about it, says any service, you should be able to rewrite it in 2 weeks. I said small number of weeks because I think 2 might be, you know, a little overly optimistic, but think about it in those terms as a guideline, right? Is it something that would take me 6 months to rewrite? If that's the case, it's probably too large. Is it something that's very chatty between 2 different services? If 2 different services are talking to each other a lot, there's some sort of coupling there that you might want to investigate and figure out. Is there a service that I need to break out, or is there an API in this service that really ought to live over here because, you know, this service obviously has kind of, you know, API envy and is calling this guy quite a lot. If you can't make a change to a service and deploy it without making changes to other services or consumers or so on, then you've got something to fix there, right? You've got to break that up somehow. You've got some coupling between those 2 services, and you need to address that. And that's really, you know, I think the hardest part for people about microservices, or at least one of the hardest parts, is getting that right. And it's expensive when you get it wrong, and you will get it wrong all the time. So you kind of want to get good at, you know, thinking about this and moving things apart and reasoning about what lives where and all of those kinds of topics. Now, on the other hand, you know, the smaller the service, the more things you're going to have to monitor in operationally, and the trickier your testing becomes. And I'll talk about testing in here pretty soon. So there are, you know, as small as possible, but no smaller. That's really the best anybody can come up with. You know, it's sort of one of those things where you know it when you see it. And you know, if I were to ask everybody, you know, do you have a piece of code that you think is too big? Probably you know, most people would put their hands up. So start there. You know, start chipping away at it, and you know, make it smaller. Take that big block of marble and make something beautiful out of it. So best practices. This is sort of a little bit of a mishmash of best practices, but one repository and one CI pipeline per service. And the thing that might be a little bit controversial here is the one repository part, right? Because now you're managing multiple repositories. But there's actually a lot of benefits to having that isolation, right? You cut down, eliminate, you know, to some extent, the ability for an engineer working on service A to do anything to service B because they're not even in the same repository. Right? So just as you have that process boundary at the API layer that kind of keeps you clean, if you can't even touch the other code, you know, you can't make changes to it. So that's good. And then one CI pipeline per service is key because, again, you want to be able to independently build, verify, and deploy that service, independent of everything else, right? So that's kind of key as well. You know, I talked a lot about, you know, one nice thing about microservices is everybody can choose their own technology and whatever fits. There's one exception to that everybody sort of, you know, kind of insists you should do, which is every service should have a consistent logging and kind of monitoring output, right? Same kind of formats, same kind of events, same backends. You know, if you use Graphite, everybody talks to Graphite. If you use StatsD, everybody talks to StatsD. You know, those kinds of things. That is, I think, one thing that is pretty important to get some standardization across all of the services. You can still use different technologies to do it, but you know, the endpoint ought to be that, you know, all my monitoring data ends up here, all my logging ends up here, and the formats are consistent. You know, timers are named consistently so that you don't have, you know, response time in one service and RSPTM, you know, in another service and that kind of stuff, so that you can really reason across your services, because that becomes important. You're no longer making method calls to a library that's in process, right? A lot of the things that you're doing, you're not going to travel over the network. So you need to be resilient for that. And there's a lot of libraries out there. You know, Netflix has put out a ton of stuff to help with this. Hystrix is a good library that kind of sits in between you and other services that you consume, and acts as a circuit breaker, acts as a, you know, kind of a canary to figure out whether things are broken that you're trying to talk to, handles timeouts, you know, all of these kinds of things. Also can help you from flooding other services. You can throttle how much stuff goes out through there, and so it's a pretty interesting library, pretty interesting pattern for doing that kind of stuff. And again, avoid premature decomposition. Stay monolithic in the beginning. Don't try to split everything apart into a million pieces until you understand it. A lot of services now are starting to think more in terms of event-based interaction than just API kind of request response type interaction. A simple example would be we have a service for creating customers, right? So I have an API that says create customer. Now, as a result of creating that customer, I want to do a couple of things. I want to send them an email saying welcome. Here's stuff you can do. I might also want to do a credit check or do something else. Now, I can implement that by having my customer service make a call to the credit checking service and do that, and then I can have them make a call to the email service and say send an email, or and this is becoming more and more popular, I could just send an event out into the world that says, hey, I just created a customer, right? And the credit checking service subscribes to that event and says, all right, I better go do that thing, and the email service kind of does the same thing. That reduces your coupling a lot more. Now, if you have a new thing you want to do, when a customer record gets created, you don't necessarily even have to touch the customer service, right? You can just subscribe to that event and do whatever you need to do. So that further helps you decouple things. Postel's law is another important one to sort of keep in mind. Be conservative in what you do, be liberal in what you accept from others. So when you're getting a response from another service, don't be too nitpicky about what's in there. Be a little liberal about what you accept from other services, so that if a new field shows up, it doesn't blow you up or those kinds of things. On the other hand, when you're sending something out, be very careful not to change arbitrarily. Be very careful not to screw other people up. And if you do both of those things, then you tend to decouple quite nicely. So testing. If you're doing a lot of manual testing, don't even bother thinking about microservices. Fix that problem first, right? Automate your testing. Automated testing is going to be key it's key in general, but especially if you're going to do microservices, because you're going to be moving things around, and you need to have confidence that after you move them around, things still work, right? Unit testing and service level testing is kind of where the bulk of the testing should be. The kind of the net of this is end-to-end tests are going to be very expensive and complicated. You want to have less of those. You want to have, kind of as the fourth bullet says there, it's like you want way more unit tests than service tests. You want way more service tests than end-to-end tests. Kind of want that in a pyramid, if you will. Use mocking so that when if you make a request from another service and you want to verify that request gets made, that there is a side effect, use mocking to do that, so you don't have to have that other service up and running. The one thing I've seen that sort of, I talked about having one pipeline for each service. Where people diverge a little bit on that is what I've seen quite a bit is when you get to the part where you want to do end-to-end tests, everybody kind of joins into a single pipeline at that point. And then you kind of have some decisions to make, right? Do I want to run with all the services as they are in production now, or do I want to run against the ones that are about to be in production? So you may have multiple end-to-end tests that you have to do, or you may, there's other techniques that you can do as well, which I'll cover in the next slide. Performance testing is going to be really important, right? Because you are introducing latency into the process. A method call in a monolithic application, always and forever, will be faster than a round trip over the network. That's just a fact. We accept that as the cost of being able to get all the benefits of microservices, but we need to measure it and make sure that things are well. So measuring and monitoring, I'll get into that in a second. And flaky tests are the devil. Flaky tests leads to all kinds of bad behavior, right? It's the you accept that things will be broken when you have flaky tests, and people stop paying attention to broken builds and those kinds of things. So this probably doesn't really even have anything to do specifically with microservices. It's just I'm on my hobby horse now. Flaky tests are evil. Either get rid of them or fix them. They really, really don't do you any good, and they do quite a lot of harm. Talking a little bit about environments and deployments. Again, a lot of this is sort of motherhood and apple pie, and not necessarily just for microservices, but keep your environments as close to production as possible. avoid kind of drift in the environment as you get closer and closer to production. You get less surprises along the way. The most common pattern that I've seen is sort of one service per host. And nowadays host is kind of an ambiguous word. Is that a VM? Is it hardware? Is it a container? That kind of stuff. But if you have one service per host, then you're minimizing the impact of that service on other services that might be running on that host. So if you have a runaway service, it's not going to degrade other services running on that same host. Yes, if you've got a bunch of VMs on a single, physical piece of hardware, eventually you'll have some fallout there. But hypervisors have techniques to limit the impact of those kinds of things, and you minimize the impact of a host outage. You lose one service, and that may be one service that's replicated, and you don't care. VMs and containers make life easier. The notion of immutable servers has become fairly interesting and fairly popular. I've heard even of organizations where what they do once they've done a deployment is they throw the credentials away. They never ever touch that. They don't log in and do anything. If they have to fix that thing, they build it from scratch and start over. And that's one way to make sure that your environments don't drift at all. PaaS solutions can be pretty helpful, but they can also tend to push you into certain technology decisions. If you choose a PaaS environment that's very Java-based or very Ruby-based, those kinds of things, they can kind of push you into making technology decisions that leave you with not as much flexibility. Now, you might be fine running those things which are Java or Ruby in the Java Ruby PaaS environments and running stuff that's built differently in different environments. That might be just fine. And automate everything. Right? Automation is going to be key to a lot of this. There's a lot of moving parts, and you need to get them right. Now, so thinking a little bit about the mean time to recovery and mean time between failure. Right? There's a point of diminishing returns with testing, especially with expensive end-to-end slow kind of testing, you're never going to be able to find all problems for production. Right? So you want to worry just as much about what's my time to recovery as what is my mean time between failure. Right? If your mean time between failure is 10 seconds, then yeah, worry about that first. But at some point, you're better off getting really good at doing things like green-blue deployments or canary deployments, or being really good at rollbacks, and push something out, and if it doesn't work, immediately pull it back. Or do a canary deployment where you start sending a little bit of your production traffic, or even copies of your production traffic to these new services that you've just deployed, and monitor them for a while and make sure that they're working. And then if they're working, deploy them more. Or do blue-green. Do a new service deployment into your blue environment, switch over the load balancer. If things go to hell, switch back. Those kinds of things. And because you're really, and the other thing, sort of the other point about that is, not all services have the same durability requirements. A login service better be available, pretty much all the time. Payment processing systems, well, maybe they need to be available all the time, or maybe you're okay with saying, well, we'll just process that payment a little bit later. Or if you're writing if you're pulling in a set of recommendations based on the search that I just did, if that responds in 500 milliseconds instead of 100 milliseconds, that's not necessarily an outage, right? I may be able to address that by just rolling forward, fixing the problem, those kinds of things. So you won't get perfection out of testing, so you need to be aware that once you're in production, you're gonna need to worry about that. So a few other things to look out for. The services will evolve over time. They're going to split. They're going to merge. Those kinds of things. You can avoid that a little bit by not sort of prematurely decomposing. The other thing that people don't often think about right up front is reporting. If you're going from a single database instance with all of your data in it that you can very nicely report over, or just kind of slam into a data warehouse, that's going to change. You're going to have multiple database instances. You may even have multiple database technologies and non-RDBMSs to deal with. So if reporting is a part of what you're doing for your application, whether it's for end users or for back office, that will have to change along with it. And kind of much more important is to understand too the 8 fallacies of network computing or distributed computing. If you haven't seen that, Google it. It's a list of 8 things that you need to worry about. The number one is the network is reliable, which it isn't. And that becomes much more important to know when you've got a bunch of services talking to each other over the network. There's going to be latency, there's going to be bandwidth restrictions, there's going to be partitions, all of those kinds of things you need to look out for and worry about. And then also be careful about how you expose your data objects over the wire. Don't put a bunch of data in there that isn't necessary, right? That'll slow things down, and also you increase the chance of coupling, because somebody will say, oh, that looks like a primary key, I'm going to stash that away. And then if you decide to change your schema or change from using integers to GUIDs or something like that, you've now introduced kind of unintentionally a coupling between these two systems. So you need to look out for that as well. A little bit on monitoring. Nikhil sent me this picture. I think it's fantastic, or this tweet. If you have a monolithic service, at least from an ops perspective, monitoring is pretty easy. If something goes wrong, it's the monolith, right? It can't be anything else. As you have a large number of services, tracking the root cause of a failure can get pretty complicated. Yeah, it failed in this service, but was that because I got bogus data from this service, or did I get a timeout and I didn't get the answer, or what? Is this a cascading event from 2 or 3 services? So there's a bunch of kind of best practices that people apply. As I said before, logging and monitoring data should be emitted in a consistent fashion across all the services. Latency and response times are very important to keep track of. Host, CPU, and memory, obviously. Aggregating the monitoring and the log data into a single place. Now that you don't have a monolith, you've got multiple places you may have to go to look for this data. So try to get it into one place. Logstash, all of these things that are out there are helpful. Log early, log often, because you're going to have to do some spelunking when something goes wrong. Understand what your services look like when they're well behaved. Right? This one usually consumes a lot of CPU at full load. This one doesn't. Today it's consuming a lot of CPU. What's wrong? Right? You sort of need to start to understand how to do that. Now, the good news is you can. Right? That kind of stuff would be much more opaque in a monolithic application. Because your CPUs are always going to be busy. You can't tell that this particular piece of code all of a sudden is misbehaving. So you've got a lot to work with there. And then use techniques like correlation IDs to track requests through the system. So, if something comes in through the primary kind of gateway, attach a correlation ID to it that's unique, and then make sure that ID travels all the way through the system to whatever services, are related to servicing that request, so that if you need to trace something all the way through, you can use that correlation ID to get a picture of what happened across all of these different systems. Some resources, all the presentations are going to be online, so you hopefully don't have to write these things down, but these are a bunch of kind of blogs and books and interesting conversations that I used primarily actually to construct this presentation. All of them are pretty interesting, and I'd encourage you to go read them. And last but not least, any questions? What's the equivalent of an ESB for microservices? I think messaging products are probably about as close as you can come. I think the challenge with ESBs become a little bit that you get technology coupled. I didn't cover this explicitly, but one thing that people kind of warn against is you might be very tempted to create client libraries to consume your services. But that can introduce coupling, right? It might make it easier to consume your service, but that introduces coupling. And ESBs have that sort of flavor to them a little bit too, that I need to write to a particular API and those kinds of things, whereas more of a publish, subscribe, event-based model can be more flexible. So ESBs aren't necessarily that evil. They may even play a part in a microservices architecture. Yeah, so there's stuff like JGroups, Zookeeper. Well, that's not really, well, you could use that for service discovery as well. That can form kind of good backbones for service discovery. For if you need configuration information that you need to pull down from a central location. That's actually one of the things we did with our clustered product. Is the only thing you need to tell a node is where is the Zookeeper instance, and we pull down all the configuration information from there, so that you don't have to go copy that stuff around, and everything kind of self-configures. So there's a lot of stuff out there. Actually, if you go through some of those links there's actually tons of, and especially in the O'Reilly book on microservices, there's a ton of hey, here's 2 or 3 types of products you might want to look at in order to do this. And the vast majority of them, I think, are open source. So.
Anders, if we are in the world where we independently create, test, and deploy this blizzard of microservices, we've got this constellation of microservices out there. How do we tie them together to make sure that service A is paired with a service B that has an API dependency?
Right. So I'm going to try to restate that question just basically for the video. So if I've got a ton of microservices out there, how do I configure them to talk to each other even, right? And I think that comes a little bit along the lines of service discovery, right? So you need to come up with a way that, and ideally as sort of self-bootstrapping as possible, right? That maybe what you do is the service comes up, it's configured to talk to, say, Zookeeper or some sort of directory service, and there's a bunch of lightweight directory services, not in the LDAP kind of sense, but in the service discovery sense, that you can use to do that. And now that then becomes a single point of failure, so that has to be clustered and those kinds of things. But that way you can say, look, I need to talk to service B, tell me where service B is, and then you get connected kind of that way. But it's typically going to be, you have an explicit dependency between A and B, and so when A comes up, it's going to say, hey, I need to figure out where B is, and use the various kind of tools that you can use for that.
Do you have any advice on tools or methods for consumer-driven contract testing?
Honestly, myself, no. But I would say go dig into some of those resources because there's quite a bit on it there. There is I'm forgetting the term now. There's a technique that's been developed fairly recently around how to do kind of contract consumer-driven testing. But I'm drawing a complete blank, so unfortunately, I don't have a good answer for you on that one. But they're out there, and I mean. And it's tricky too to do this kind of testing, right? Because you're dealing with a lot of collaborators, so you've got to know where to stub, where to mock, those kinds of things, and avoid as much as possible needing 2 services up and running in order to do any testing, right? As much as possible, you want to have just your service up, and then mock and stub everything else. That's kind of key. Another technique that people use is they'll do sort of end-to-end testing in production. So they'll funnel kind of fake transactions through the system and make sure that all the right side effects happen. That can be tricky to do because you don't sort of want to accidentally, introduce bad data into the system. But it's a pretty real way to figure out whether things are really working end to end. And so quite a lot of large systems use that as well. Testing in production sounds kind of weird, but it does in fact work. Yeah. So shared, the more you rely on a set of shared libraries that every service or a bunch of services need to use, the more you're coupling them. So you've got to make sure that that's the right decision, right? Now, if that's some sort of algorithm that just every single service needs for whatever reason, that might be fine. If it's a bunch of string utilities or parsing stuff or those kinds of things, that's fine. But I think the thing to understand is if I have to use a shared library that you produce in order to make my service, I'm now coupled to your technology decisions, right? And in some sense, I'm even coupled to your release cadence, because if I need something new out of that shared library, I need to wait for it. But at the same time, it's a very powerful decomposition and implementation technique. So it definitely has a place, but it's it's a double-edged sword because you can unintentionally introduce coupling by doing that. Yeah.
How can you manage test automation for an app that changes a lot?
Well, I think where to start, I would say, is so it depends on, let me repeat the question, I'm sorry. How can I manage testing for an application that changes a lot? Well, there are different kinds of change, right? If you're changing the contract between 2 services, that's a big deal, right? That you should try to minimize that, because that will make your testing and your deployments and everything, much more, now they're going to be in lockstep and all of those kinds of things. If all you're doing is changing the implementation inside of a particular service, then your unit testing and your service testing of that service should cover it, right? So in some sense, I don't think it really gets that much different, than it is today, which is to say, in a monolithic application, I have, unit tests, integration tests, system tests, UAT, performance, all of those kinds of things. And, whenever you think of a particular piece of functionality that you want to verify, you always want to write the cheapest, fastest test for that you can, right? You don't ever want to write an end-to-end system test to test something that should be a unit test, right? Because that system test is going to be very expensive to set up, very expensive to run, and as opposed to the unit test, which is going to run in under a millisecond. So a lot of it has to do with how you structure your tests, and making sure that you are testing at the right level for a given set of behavior. And then focus, a lot, especially in a microservices environment, you want to focus a lot on contract testing and API level testing, because that's really, if you violate that bond, now the whole microservices thing starts to break down. If I have to rev this service in order to be compatible with a change in another service, things start to get difficult pretty quickly, both from a deployment and monitoring and testing view as well. So. Yeah, I think what part of that depends on whether, do the microservices consume the monolith or vice versa? If your microservices are consuming your monolith, think of it as a very large service, and again, do contract testing at the boundary, and make sure that stays valid, and don't underestimate the usefulness of lots and lots of unit testing. At some point, you also want to think about things like code coverage and all of those kinds of things. But contract testing is one of those. It's kind of a must-have for microservices, because if the contract breaks, the cascading effect of that is pretty significant. So focus on that. Interesting question. So microservices for embedded software. I mean, I think that has. So it's funny because I actually think I think a lot about how does DevOps apply to embedded systems, and those kinds of things can affect a lot of our customers are embedded, and it's one of those things where 90% of the stuff that you're going to do is going to be the same, whether it's an embedded thing or not. The 10% can be a pretty important difference. You're probably going to end up with all your services on a single device. I'm assuming. So that'll be a little bit different. Monitoring might be a little bit different when you do that. Especially if that device then goes out into the world somewhere. How you monitor that will be interesting. So there'll be some interesting changes, but a lot of it will be the same up until a certain point. Almost up until deployment in some sense, I would say. So there's still a lot to be learned from it. And you still get the benefit of, well, I don't have to rev all these other services in order to make this one change or add this functionality. And I don't have to go redo all of the testing for those services because they haven't changed. And so you still get a lot of the same benefits, even if the kind of the ultimate packaging is a little bit different.
Is there any middle ground between a monolithic architecture and microservices architecture that's worth pursuing?
I think by definition there will be, because if you start as a monolith, you're going to start to chip away at that big block of marble. So, I mean, right there, you're going to have coexistence between the monolith and the microservices. So, yeah, absolutely. I mean, for anybody that's not just starting from scratch, you're going to coexist, with a monolith for quite a while, probably, if you try to break something significant apart. So that seems perfectly legitimate. I don't think it has to be an all or nothing thing. It really doesn't. And you may have legacy things that you don't want to touch. You may have a pretty big service somewhere that you're consuming that you're just not going to touch. It does what it does. It's all that kind of stuff. That's fine. and that's not necessarily a problem. As long as it scales, as long as you don't run into any of the problems that might push you towards doing microservices. Any other questions? All right, thank you very much.